بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. أعزائي الطلاب, today we have an elastic collision experiment. In this experiment, we will show you how we collect the data for this experiment. What we have there, let me in the first explain the setup. We have the spring gun, and we have the ballistic pendulum, and we have rotation motion sensor, which will give us the angle which taken by the pendulum there. Now I will load the first object, which is the ball there inside the spring gun, and I will face the ballistic pendulum in front of the spring gun. Now the collision exactly will happen at this position. Our target, as we mentioned before, is to investigate if this collision is elastic or inelastic collision. But we know that if the two collided particles stick together and move as one object, we know that this perfectly or completely inelastic collision. To collect the data, we need in the first to find what is the velocity initial taken by the ball, and we need to know what is the final velocity exactly after the collision, and we need the masses of the object, the mass of the ball, the mass of the ballistic pendulum, and we need also to know the arm of rotation, which we call it a small r in the board there, which is the distance between the pivot points and the center of mass of this ballistic pendulum. Now let me start with the first objective, is to find the initial velocity. To find the initial velocity, we will use the projectile motion. We will fire the ball from the spring gun, then it will take the projection and hit the ground at some points. By knowing the value of the capital H, which is the height of the ball when we fire it, and the capital R, which is the range taken by the ball, we can easily use the equation to find the initial velocity, which is equal to capital R multiplied by square root of G divided by 2H. Now I fire the ball from the spring gun, and it will hit the ground at some place here. We know the place, we put carbon paper there. By that paper we can know the place where the ball hit the ground. We can know the position exactly. I will fire it again to find the value of R. You see, it hit the ground at some place here, and this carbon paper will make some dark points to appear, which reflect the place of the points. Now to measure the height H, we can use the ruler. We put the ruler there, and the distance from the center of the ball there, or the center of that spring gun, to the projection there in the ground, this distance we call it capital H, which equal to 1.04 meter. We will measure this for one time, and we call this as capital H. To find the range, the capital R, we need to know the projection of this spring gun to the place we fire the object there. We will do this 5 times. We will fire the ball 5 times. Then we will have 5 values of R, and we can use the ruler to measure the distance exactly for the first hit, second hit, and third, fourth, fifth, till fifth trial. And we know that we'll give you the data. It is about 2.4355 meter, reflecting the range which is taken by the object. By using now these information, H and R, we substitute direct in the equation to find the value of the initial velocity. Now the second part, we will use the data here in the data studio program, and we will use the rotation motion sensor. This rotation motion sensor connects to the interface, and the interface connected to the computer by the USB, and there is data studio program. When we run it, it will give us the data come from that sensor. That rotation motion sensor, we have it here, will give us the value of the angle. What we having exactly after the collision happened, the ball will hit the ballistic pendulum, and the system will move as one object. The energies we have it here now is kinetic energy. The system will move with some velocity, we call it V final. Now the kinetic energy which taken by the system here will convert completely to height, and this RMS rotation motion sensor will give us the angle taken to convert that kinetic energy to the maximum height or to the potential energy. I will take it away, the ballistic pendulum, and I will load the the ball inside the spring gun to the third position. And now we are ready. We will start the start button in the data studio program, and we will fire the ball. What we got there, we got a peak like this. If we select some area like this and select statistics, it will give us the maximum value and the minimum value and the mean value inside the selected box. What we're having here, the x-axis is the time and the y-axis is the angle in radian. This sensor gives us the angle in radian, and it is around maximum value. We are care about the maximum value, which is 0.237 radian. Now we have to repeat this five times to collect 5 different values of this theta and radian. Then we can calculate the h, the small h, which reflecting the converting of energy from kinetic energy to potential energy. This small h can be given by the equation which already explained in the board, and accordingly we can find the V final for the system. What else we need? We need to find the masses of the ball and the ballistic pendulum. We have similar one here. We can take the ball and the ballistic pendulum, put them in the balance, and measure small m plus capital M, measure the value there, and we take the ball alone, then we measure the value of the ballistic pendulum mass, which is capital M. By subtracting, we can easily find the mass of the ball. Now we want to find the arm of rotation for this ballistic pendulum. The arm of rotation is the distance between the pivot points and the center of mass of this object. The center of mass is somewhere very close to the heavy part of the object, and most probably it will be somewhere here. Now I will put the ballistic pendulum with the ball there inside on the table, and I start pushing. When it is barely want to fall down, that means we catch the center of mass there. Now the center of mass is exactly here, which means the distance between the edge of this table and this point, pivot points or rotation points, will be considered as the arm of rotation of that ballistic pendulum, and we explain it there in the board, if you remember, by r small r. Thank you.